In this video, we'll be learning how to subtract when numbers are written in scientific notation. We're going to use the same process as we did with adding. Remember, we want two things. We want our decimal values, or decimal points, to line up. And to do that, our powers need to match. In this very first example, we have 9.5 times 10 to the fourth minus 4 times 10 to the fourth. Both of these powers are the same. 9.5 times 10 to the fourth minus 4.0 times 10 to the fourth. I can just drop down 10 to the fourth. 5 minus 0 is 5. Hold on the decimal point. 9 minus 4 is 5. My solution is 5.5 times 10 to the fourth. In our next example, we have place values that do not line up. And if you remember what we did in our first video on adding numbers in scientific notation, we looked at where our powers lie on a number line to figure out how many place values we needed to move. In this case, we would have to move 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places in order for our decimal points to line up. And that is moving this decimal point here 9 times to make this equal to 10 to the 6th power. So what does that look like? I'm just adding in some values here for 0. I might have to add in a couple more. Times 10 to the 6th minus 1, 2, 3, 4, 5, 6, 7, 8 times 10 to the 6th. Honestly, this number would round to 3. Because if I make this 2 and I borrow all the way over, we have 10 to the 6th, 5, 9 minus 3 is 6, 9, 9, I should have 8 nines, 8. If I round to any of these place values, I still end up with 3.0 times 10 to the 6th. The reason I wanted to talk about this and walk through this with you is that if these two powers are really far apart, like we saw here, we don't really have to add and subtract because it's not going to make a difference on this final outcome. Also depends on the situation, but use your best judgment. If you were to round to any place value and you get your original starting number, you probably don't have to go through all the work. For this problem, 8 times 10 to the third minus 1.5 times 10 to the third, I want you to pause the video and attempt to solve this on your own. Welcome back. Because the powers are the same, this decimal point here is going to line up with this decimal point here. 8.0 times 10 to the third minus 1.5 times 10 to the third. We get to bring 10 to the third down right away. I can't take 5 away from 0, so I'm going to borrow from from the 8 to make 7. 10 minus 5 is 5. Decimal point 7 minus 1 is 6. My final answer, 6.5 times 10 to the third. For our final example, we're going to look at one where the decimal points will not line up because we have different values. Go ahead, pause the video, take a couple of moments, and solve this on your own. Welcome back. When my decimal points won't line up because the powers don't match, I want to look at a number line. It's a habit for me. It's such a habit that I think about it. In my head, I don't always have to write this out. But if I have 1.0 times 10 to the negative 7, and I want to make this one negative 7, my decimal point is going to have to move 2 places this way. So this is going to be 100 times 10 to the negative 7th. I'm going to bring down 10 to the negative 7. And 1 minus 100 is going to be negative 99. I need to move my decimal point 1 place to the left, so I add 1 to my power. This is going to be negative 9.9 times 10 to the negative 6th power.